Hello all, welcome to today's video. Hope everyone is doing fine. And today we'll be mainly discussing about task parallel library in .NET. So before proceeding further, if you are new to this channel, please do subscribe to this particular channel to get notification of the new content which is being uploaded. And I do have a blog which you can check out in the comment section below or in the description box below. Therefore, today we'll be discussing mainly about the task parallel library and the deadlock which can result when we try to use the task parallel library without having much understanding of it. Therefore, before going to the deadlock scenarios or scenarios in which can happen, I'll be trying to explain what basically is a synchronization context. Therefore, if you try to understand the synchronization context, then only we'll be able to actually understand when in which scenario deadlock can happen when we try to use task parallel library. So, what is the synchronization context? So you can imagine the synchronization context in simple words as a context, an environment where a particular code is executing. If you write a particular code, that particular code will be executing in some environment conditions, or in some environment it will be executing. Therefore, that environment is actually termed as a synchronization context. For synchronization context, essentially captures the environment in which your code is executing. So that's in simple words. This is what a synchronization context is. Therefore, each of the framework, that be it .NET framework or .NET Core or some other framework, actually captures the environment in which the code is executing. And when you try to switch the thread, or when you try to switch from one thread to the other thread, what happens is the current environment is captured into one synchronization context object, and that object is passed across to the other thread, and that particular other thread will decide, based on the implementation detail, it will decide whether to execute that code in the synchronization context which is passed to it. So essentially, that is what a synchronization context is, and each of the thread will have its own synchronization context. So the main things we have discussed about what is a synchronization context. Then we will proceed to when a deadlock can happen when you try to use task parallel library. Basically, if you try to use the asynchronous pattern, when a deadlock can happen. So essentially, what I guess most of you are familiar with what a deadlock is and what when that particular deadlock happens. Deadlock can happen when two different threads are actually uh, trying to use or trying to use the same resource um, within a particular program. When you try to use the same resource, and the resource, if it is locked by one thread, the other thread will not be able to access that particular resource, and there that will happen. There is a resource contention which is happening there. In other words, if you try to simplify it, what happens is when a particular resource is there, and when two different threads are trying to access the same resource, individual thread each of the thread is not able to get hold of that particular resource, and it is not getting a clear majority of that particular resource. Here in the taskbar library, there are broadly two scenarios where that particular deadlock can happen. So scenario one is when the caller thread is a thread pool thread, and the task is scheduled to execute in the thread pool thread. Therefore, it is not mandatory. Therefore, one important point to note here is it is not mandatory that the is definitely task will definitely get executed in the thread pool thread. It is not so, because when the caller thread is a UI thread, and it does has its own synchronization context, and then by default the task, if you write a task in the UI thread, by default that will execute in the UI thread or the calling thread context. Therefore, in the scenario one, if the caller thread is a thread pool thread, and the task which is scheduled is also scheduled in the default task scheduler, which is a thread pool thread, and deadlock can happen if the system load is high. In the sense, if most of the thread pool threads are occupied with some other task, then there will be no thread pool thread free to service this request. Then in that case, that the deadlock can happen. In this, I have given one example where we are trying to get some data in an asynchronous fashion. It's an async API, and when we are doing dot result on it, that means we are blocking the caller thread. Here, the caller thread being the thread pool thread, and the task which is there is scheduled to execute on another thread pool thread. Therefore, what happens is when the thread pool is okay, or no threads in thread pool are free, or most of the threads in the thread pool are occupied with some other task, there will be no other thread which will be able to service this request. And since the other thread pool thread is waiting for this result, it can result in a deadlock because there is no resource available, or resource contention happens there. So there, the deadlock can happen. And the other scenario where the deadlock can happen, which is most common, which is we can actually uh, ascertain that in this scenario the deadlock will surely happen. The other scenario that I'm trying to discuss is when the caller thread is a UI thread, which is having the synchronization context, and by default the task will be scheduled on the on the UI thread. And when we are trying to do like this, when we are trying to do get data async dot result on a UI thread calling context, then what happens is the task is scheduled to execute on a UI thread, and that the same UI thread is getting blocked by doing this dot result. Therefore, that thread is actually blocked, and it will not be able to execute the task which is scheduled to it. So in this case, there will be a sure deadlock which can happen for the other above scenario. So these are two broad scenarios where a deadlock can happen when we use the taskbar library. For to main way to avoid the deadlock using a taskbar library is to use that async await pattern. If you try to use the async await pattern instead of actually doing this dot result, this will surely avoid the deadlock, because all the because the caller thread in this case is not at all blocked. It is free to execute its own task. That is the main advantage of this async await pattern, because the caller thread will not be blocked. Unlike the scenario that we discussed before, where we are trying to block the caller thread using the dot result. In short, any code, any taskbar library code where we are doing that dot result, it can result in a deadlock in some scenario or the other. If the it can especially result in a deadlock if the system load is too high. So that's what I wanted to communicate here. And these are the two broad scenarios where the deadlocks can happen when we try to use the taskbar library. So thank you for joining in. And if you like this video, do press on like button and do share your thoughts in the comment section below. And do share this particular video in your community groups. Thank you, and catch you in the next video.